Okay, so we are going to study the structured data today. Let me share the slides completely. Yeah, now we are going to study the structured data today. So the first thing first, uh, I mean, when you talk about the structured data, you know that we are going inches forward towards the object-oriented programming. Why? Because the object-oriented programming deals with the real objects, you know, the real objects in the software, and the structured data somehow it gives you some sense of the object because you are presenting certain what we are going to learn here, that how to present certain artifacts, I mean software artifacts, like let's say you are going to do a bank account, going to create a bank account programming. So how do you represent the bank account? So basically you have the data, right? I mean, you have different data types, you have different data, and you create a structure out of that, so that in our when we solve the real world problem, we can implement those structures wherever it is appropriate, and we can reuse those structures. Only thing we have to do, once we define the structure, we have to we have to implement the structure and set the data onto the structure. That's how we are going to build a structural programming, which is basically the older version of object oriented programming. I should not say that the older version, but it is kind of you will sense that we are going towards building an object. Anyways, so what are the abstract data types? I mean, the abstract data types are simple data types that are created by the programmer. I mean, the abstract data types are abbreviated as ADT. ADTs have their own range of data and their own sets of operations that may be performed on them. You know, um, do you, is there anything that comes to the mind whenever we talk about abstract data type? Any example, something like that? No answer is bad answer. So let me start attempt to answer. So let's say in your C++ programming, so far you have used the integers, right? So, integer is what? Integer is a data type. So along with the integer, what are the what are the operations that are available with the integer? So you have the integer x in your program. I'm not including, I mean, input, output. Let's say everything is there. I'm just excerpting couple lines from our program. So integer x equals 5. Now you can always you can define another integer y equals x plus 10, right? There is no problem. If there's a requirement, we can do that. So what we learn is that along with the integer, you have an operation available to it, that is the plus, addition. Similarly, you can do multiplication, you can do division, you can do subtraction, you can you can apply modulo operator as well, modulus operator. So integer is an abstract data type because it has uh, their own range of data, right? I mean, there is a limitation of the bytes on the integer, and then they have their own sets of operations. Now, the ADT is very important. This concept of abstract data type, or ADT, don't confuse with security company, any security company. This is a pure computer science stuff. So this is different. This is the computer science abstract data type. It's very important, and this is especially significant in, object-oriented programming. Now, the abstract data type has the first part, which is called, abstraction. The first part of the abstract data type is the abstraction. And what is an abstraction? Uh, an abstraction is a general model of something. This is a definition that includes only the general characteristics of the objects. It does not show any details. For example, the term dog is an abstraction. It defines a general type of animal. The term captures the essence of what all dogs are without specifying any any detailed characteristics of any particular type of dog. So that's pretty much our abstraction is. So here, for example, abstract triangle is a three-sided polygon. So this is your abstract triangle. You don't say that what type of triangle it is. You don't say what kind of what are the measurements of the different sides. You don't say that. You just say triangle. So triangle is an abstraction of a three-sided polygon. So now the data type, the second part of it, the abstract data type, we had the abstraction, and then the second part of it is the data type. So C++ has several primitive data types. I mean, data types are the values that can be stored in a variable and operations that can be performed on it. So integer is a data type because you can store a value for an integer and you can do some operations with that particular data. So that's the utility of programming, right? I mean, you have to define some data type. You have data. I mean, data is everything. Now, how do you set that data in a structured way? That's why you need some abstract data types. Now, in C++, there are multiple um, primitive data types, such as you have I mean, Boolean, short integer, long integer, I mean, float, double. Those are all primitive data types. So you can get a list of that in your book. I'm not going to uh, explain that in a detail, but it is available in a table 111-1. This is chapter 11. If you read the chapter on 11-1, you will get the primitive data types. Now, we are our next task is combining the data type into some structure, you know. So what does that mean? I mean, the the concept of structure is like that. I mean, C++ helps you to group several variables together into a single term known as a structure. That's not very clear definition. I mean, it's a very, I would say it's a very abstract definition. Let's make it a little bit clear. So, you know, let's say you have a school, right? In the school, you have students. Now, you can define a student data type. Now, these student data type, there are multiple data on the student. So, a programming language like C++ will allow you to group several variables together. So what are the attributes of a student? Let's say the ID, student ID. You have a student ID. Whenever you talk to your school, you have to present them with your ID. Then you can have the name. Of course, you have the name, ID, then name. Then you can have the uh, I mean, you may have you will have the birth date, etc., etc. But other than that, specific to the school, there can be other identifiable thing like attributes, like for example, your level or year. Maybe you are in the first year, so maybe you can say year. Then you can identify yourself enrollment. enrollment status, enrolled or not enrolled, things like that, and so on. So basically, you have several variables for a student. You can group them together into a single item known as a structure, and this structure's name is student. Okay? So whenever you call someone a student, you think about several structural attribute for them. You cannot just call a random any random person a student. Whenever they are affiliated to a school, whenever they have their student ID, of course, and they have the enrollment, they have class, then only you have the student. For example, lot of insurance companies give students discount, good student discount. How do they identify a student? By through these structural attributes, you know. So you have to show the evidence that you are a student to them. So that is your structure. Now the the combining data into the structure is very. It looks like that. I mean, you have the construct that allows multiple variables to be grouped together. So general format. How do you write a structure? It starts with the keyword struct. You know, it it starts with the keyword struct. Whenever you define a structure in C++, your keyword is struct. Whenever you declare a keyword struct, that means you are making a structure. Then you have structure name, then you have the data type 1, field 1, and so on. So basically you can do struct, and let's say you have a struct student. I'm just writing it as stu2. Then you can have integer int id. Let's say you can say int year, then you can say string school, and so on. And at the end of this curly brace, you put a semicolon. That's how you define a structure. That is the keyword. I mean, you know, you cannot define a variable named struct in C++ because it's a reserved keyword. So struct is a special keyword that allows you to create a structure. Okay, so that's how we build the structure. Now, exactly the thing that we were talking about, the student, I mean, you can have, this is the structure tag. This is called the structure tag, or you can say it structure name. Then you have the structure members like student ID, name, year in school, and GPA. These are the four important uh, structure members. Then, you know, this is mandatory. You have to have struct, then the struct name, which is student structure tag. Then you have a curly brace. You must have. Otherwise, guess what? Your program will throw exception, error. It will not compile. Then this one will be ended by a closing curly brace and then this semicolon. This is a very, very frequent mistake people make. They define a structure and they don't specify the semicolon, and then they keep on compilation failure. So that's very important. This is very important to remember. So the struct names commonly begins with uppercase letter. So struct names means the student, this one. Um, so this why the struct names begin with a uppercase letter, because you know it's like a noun. So whenever you do some struct, you are referring to an object, so which is a noun. So that's why probably it is a convention that we begin with a uppercase letter. Then there are multiple fields of the same type can be in comma separated list. For example, you can have the name, address. So basically, you are defining the variables in exactly same way as you do in any average code, average C++ code. So, I mean, you could have, you remember like you can define some variable like int x, y, and then you can say, you can even initialize z equals 0. This is absolutely legal in C++. But something is legal does not mean that it is a good practice. I personally do not prefer to write code in that way. This inline definition of data type is one of the practices which is not very good because it makes code little bit unreadable. Imagine the situation you have five you have 50 variables listed. You have, let us say your code deals with 50 variables and you are just defining them all together as an integer. You don't know, you cannot keep track of them, and you don't, I mean, it's absolutely unreadable. So always like define the data type and variable, put a semicolon, define another data type, another variable, and so on. So in the struct, it follows the same rule. The legality is the same, but practice also applies to the same. Like don't use too many variables together. Now, um, so what I'm trying to say here, this one is legally correct in C++. It is allowed, but it's not a good practice. Now, the variables are defined in this way. Struct declaration, uh, I mean, it does not allocate memory or create any variable. To define variable, you know, use structure tag as the type name. So when you do the struct, I mean, you define something here, right? This one. Does this book any memory? The answer is no. It's just a representation. I mean, whatever the file occupy occupies the memory, that is it. There is no memory space, memory in the programming space, there is no memory by the definition. But whenever you just use the struct as a data type, then you are going to book some memory in your memory structure. Always remember that. So you have a student, I mean, this is the struct name, then instance of the student, I mean, any student, let's say Bill, William or Bill, he is a student, Jane is a student. So whenever you create a student called Bill, then you are creating a footprint of student struct in the memory. Okay, so that's how you um, you deal with the memory when you define the structs. Okay, so that's the variable declaration. Now the next thing is, well, I mean, we define the structure. How come I can access the the variables that I have defined in the structure? You know, how I can access the variables in the structure. So let us illustrate it by an example. Okay, we have done a lot of discussions. This is the time of some time for some live coding. How about that? So here, let me reclaim this space, this terminal, and let me close everything here. Closing everything is a good practice because then you are starting from scratch. There is nothing in the past. I mean, things like that. So you can create a new file. So new file, you can say you can write it as struct struct example one dot cpp. Okay. This is our file. Why I'm creating this way? Oh, that's doesn't matter. We are creating a file, and this is the file. That's fine. Now, as the next step, what we are going to do? Our problem. What is our problem? Let's define a fictitious problem. Like let's say we are defining a payroll. You okay? So the whenever you define a payroll, let's define the struct first. Now, the thing is, whenever you write a program, sometimes our habit is to start it by the include statements. I mean, this is uh, this is the same. I mean, this is fine. This can go on. This habit we can continue. Like we can use these ones. But then, um, whenever you are dealing with the struct, you should declare the struct in the very beginning. So you define struct and then you define payroll, let us say. That is our struct. And then, we have the variables and uh, I mean the attributes of this. This is the name tag. This is the tag of the struct. And this is our structure. I mean basic shell of the struct. And then we can define int employee number, okay, string name, that is the name of the employee. So we are creating a payroll software. Double is hour. This is the decimal, I mean double precision. So double, then you can say pay rate, double gross pay. So this is a nice struct. You see, this is a very, very, very simple struct. So you are basically doing what? If you would write it not like a struct, you would have to define all these variables and play with all these variables. But in this way, you are grouping all these variables under a single structure. So that is a very nice way because these variables are of course related and these variables are related to the payroll. So rather than handling the variable like in an ad hoc mode, like in a typical procedural programming language, we took advantage of C++ and defined a struct that way. So now comes the main program. So we define integer main this way, and then we can end it by ending curly brace and return 0, which is our shell for this program. Now we have to use this struct. So our problem was, I mean, when we started this description, we were trying to learn how do you access the variables in struct. So first of all, how do you use the struct? We have already learned that. So we have to create a, um, I mean, a data type. We have to define the data type payroll. So when you define a struct, it acts as a data type, and you can say it define a data employee. So this is a payroll structure, and then what you can do, you can just one by one you can enter the information and set the variables. So you do cout. You can ask the user to enter the employee's number. Okay, so you can now do cin and you can do, now you can use employee. This is your struct dot emp number. That is how you access the variable. You put a dot after defining a data type, you create a variable. Here payroll is the struct, employee is a variable. Like you do integer x, where integer is the data type, x is a variable. Here payroll is the data type, employer is a variable. Then you put employer dot, you have to use the dot symbol, employer, employee dot employee number. So you are getting this from your user. Now you can do similarly, you can do the employee name, but this is a string, so it's better to do it in a different way, not just see in the above way, this way. This is good for numbers, but for string you can do the get line. So you are just removing the this new line characters by doing the ignore. Then next step, you can define the hours worked by those employee. So you can do the similar thing. You can start doing the similar thing. You can just write um, this way, how many hours, and then you have the within the struct you have it should be hours, not the hour. So you have the hours. So you see the way we access the variable is the name of the structure, name of the data, or it's a variable or identifier, and then dot. You have to use a dot symbol. That way you can access the variables in the struct. So then there are more variables, I guess. So hourly pay rate, let us say the next thing to set. So you can do it in this way. What is the employee's hourly pay rate? And finally, what you can do out of it is that you can um, calculate the gross pay. So how do you do that? You can just define the gross pay in this way. I mean, hours times pay rate. So then that's how you access this variable, and then you can display the result as follows. Like you can write a lot of things, but basically this is how you can display the results. So you see we define the struct, and this is not within the main function. Always remember, you define the struct, it's an independent code. It goes in the top to the top of the function, and then you have the main function where all activities are happening, and then you access the member variable by using the variable name dot its member name. The dot symbol is crucial. So that's all we wanted to do in this program. Let's save it and then we can run it. So we can create a new terminal. Oops. So we can do like this, new terminal. So here is my terminal, and we can do G++. Then we can do struct, sorry, struct example1, and then we can give some executable file name struct1.exe, let us say. So then if we compile it, what's happening? Cannot find struct1. Oh, it should be -o. Yeah, of course it won't find the executable file. So that's it. We compiled it. Now you can run it. struct1.exe, and then you run employee's name. Let's say Jane DOE. What is happening now? Here is the employee. What is happening? Let's see. We have some issue here. We did uh, like see in employee. So what we did employee dot name. So skip the remaining part. So here something happened. What is the employee's name? And then it started to um, fast forward these things. So we can do like how about doing in this way? Let's do this in this way. Like C in name. Okay. Let's try that. Sorry, employee.name. So if we do that, and then if we compile it and run it, so we can do Jane DOE. No, it doesn't help. So once you enter, everything gets entered, and then there is no way you can do anything. What's happening? To skip the remaining, it is somehow ignored. I don't know why it is getting ignored all the time. So did I put this? Yeah, I did. I think I did put it in the correct way. Let's see. See in get line. We are doing the get line. So let's see. See in. See in. I mean get line. That is fine. Now if I let's do a clear. Okay. So G++ struct one. Let's say I am doing G++ and then this one dot a.exe, that is the default executable. Do test, let us say, but then we have those issues there. So the problem is it is not. So is it the problem here? Are we going to get this problem if I are we going to skip this problem if I just as a whole clear this one? So test, let us say employee's name, but then no. If I enter, everything gets entered. So that's a problem. So let's not bother with this input output problem at this point. I will try to see how we can solve, but let's set the numbers by hand. Let us say we can access the variable. That is our goal today to like to get this variable um, accessed. So we can do like oh, that's the problem, probably. That's the reason it failed. Probably I got it. So employee number, it should be it should be a number. It's not a string. Maybe that's the reason we are getting the error. So let's try it again. So this one and then this one. Employee number is 12345. Yeah, now it works. So let me clear and start doing this again. So here employee number is 12345. Then employee name is Jane DOE. How many hours did the employee work? 40 hours, let us say. What is the employee's hourly pay rate? $25. And then you have the payroll data. So you have name, number, 40 hours worked, and gross pay is $1,000. So that works. Everything is sweet. Why we had the mistake? Because we were inserting a string in place of an integer. That's why we had that problem. So what we learned from this exercise, the most important, how do you practically declare a struct? So it is a standalone definition. It's a simple example. The struct can have methods and functions. We are not doing that here in this example. And then you do the main function where you define basically you use this data type and create an identifier or a variable, and then you access the members of this variable, this data type, this variable, and then you start setting it. So once you set, you again access them and then you display those. So we learn how to declare a struct practically, and we learned how to access individual members of the struct. That's those are the two things that we learned from this exercise. Anytime you have any question, don't hesitate to um, tell me. I mean, you are more than welcome to interrupt me. So I'm not going through this detail. We have already this payroll exercise. Of course, we have done this. So uh, you are displaying the struct variable. We have seen how do we display the struct variable. I'm just now here. Uh, there are you cannot compare the struct variables directly. Like for example, in this case, let us say you have the student. I mean, not the student. I mean the employee, the payroll. Let's say we have um, two employees. Okay, so let's say we have another situation where we define the second employee. Okay, so here we can say employee 2, and then we can use employee um, as employee 2. I mean the second employee we are defining. So that's how you're accessing individual values. So this one, okay. You may note that, I mean, the variables are exactly the same. You know, the employee 2, all the variables, we can say make them exactly the same. Then can we compare like this? If let's say employee equals employee 2, we can say C out employees are identical. Can it happen? So the answer is no. What is happening here? Um, so because these no what is going on? Employee equals. It should be equals, right? So you cannot use these with the struct. You know, it clearly indicates that this variable cannot go with the struct. You cannot compare two structs in this way. So then you can ask, how do I compare? So that's a good question. So the way we should be comparing, let's see. I mean, it should be by exploring the values. So you have to do you have to compare on a field by field basis. So you have to say that here in the program that here you can say if employee ID, I mean employee number equals employee to number. If they are same, the employees are identical. Of course, the numbers are unique in a system. So that's the way you can make two employees to be identical. So the moral of this particular segment is you cannot just use your variable to understand whether they are same or not. And then how do you establish the equality? It depends on what type of variable it is. If it's an employee, having employee ID to be the same should be enough because no two employees can occupy a same ID. But then you can have different problems and then you may involve more and more membered variables for this comparison. Okay, so that's pretty much how you can do it. I'm not running the code, just coded it so that you can see the basic structure. Now, you can always initialize a structure. I mean, there are multiple ways to initialize the structure. In one way, you can define individual value by value. That's what we did in our previous example. But you can also initialize by using this curly brace, this notation, you know. You can always define the struct in that way as well. So there are multiple ways to define. So this is also a viable way to define a struct. So in your example, for example, let's say, I mean, in our example, if we were to define it in that way, we would say, let me do one quick thing. Let me comment it out. I mean, let me delete it completely, and then I can define it in this way. Like you can say payroll employee EMP equals you use your ID, then you can use the name. Is it right? I mean, what did I do? Yeah, that's fine. Name as Jane, let us say. Then we can do the hours, 40 hours. You can do the pay rate, $25. Then you can use the gross pay. You don't know the gross pay, you know. So you can just set it to be zero for the time being. And then if you just, I mean, or you can do, you know what, you can set it zero, but then you can do EMP dot gross pay. You calculate it like EMP dot hours times EMP dot what um, your pay rate, and don't forget semicolon anywhere, and then you can do C out. You can do EMP dot employee number, EMP number. Then you can define EMP dot name. Let's say I'm doing that gross pay. There are other variables to display. I'm not displaying those. So if we do that, then if we run the program, let's see what happens. So we can always compile it in this way and then we can run it, right? So you can see 1, 2, 3, 4 Jane and then $1,000 is calculated. So this is another way to declare struct. So either way is good, this way or that way. And there is no better or worse way to declare. All ways are equally likely, equally good. So you can initialize only some members. Like in our example, we did not have to, we did not have to declare everything. Here, we did not have to declare this guy. Still, we could survive. I mean, you can put a comma out there. Comma can be there, and then if you can just this one, and then if you execute the code, you will get the same number. So you may not need to define, and more interestingly, you can end it with a comma, or you may not end it with a comma at all. That way also the code will compile and produce exactly same result. Okay, so that's how you can. That's about the declaration of struct. Now, so that's what we did, and let's not. I mean, that's what we did in our programming exercise. Let's not do a lot of discussion about that. Now you can define the arrays of structure. Before doing that, let's give a quick break. Let's say let's come back around 8 p.m. A 9 minutes break. Let's use it as a bio break, whatever you want to do, and then let's come back at 8 p.m. and we will resume the remaining part. So when we study the arrays of structures, so like any like variable, any data type, for example, you have arrays of integer. Similarly, you should have arrays of structure. So that's what we are going to learn here. So you can define the structures in an array. So to to add more like more information about that, let's like it can be used in place for parallel arrays. Like for example, you have the number of students 20, and then you have the student. You can do the student list, and then number of students. Just like, I mean, if you do integer, let us say integer values, vals, let us say that is your arrays of integer. You can do n. N is a constant, and then you can define these vals in an array, right? It's the same way. The definition of the array, I mean definition of the structure in an array takes place in the same way. I mean you can define it in the same way. So I mean individual structures accessible using the subscript notation. So that is your um, like you have this one. This is your index of the array, and then you do the dot student. I mean that's how you can access the individual array. So I mean how do you understand that? So basically you want to, what is the problem here? You want to, here I'm talking about accessing individual uh, structures. So how do you do that? So this is a list of, let us say, 20 structure. How do you define, how do you access the 10th structure? The answer is you have stu list 10. This is your 10th structure in this list. It starts with, of course, 0, 0 to 19. So that is your 10th structure. So this is a structure. This is not a variable. If you do couts to list 5, for example, or 10, it will not print anything. It will print the individual variable, that is the student ID. So you have this guy, this one represent a single structure because it's the index of the array. For example, here in the integer array, vals represent an array. Now, if you do vals, let us say 5, then it represents the fifth value of the array. Maybe this has some number, maybe it's 10, let us say. I mean, I'm just giving an example. Here, similarly, you have the student. I mean, in a school, there can be thousands of students. So each of them are represented in an array. So fifth student is this one. So this is a single array. And then you can put the dot, the accessor, the subscript, I mean the dot notation, and then you do the dot student ID, and then you can this gives you the student ID of the fifth student in that array. Okay, any confusion? So this is the example. I'm not going to work out this example, but leaving it to you to practice. But this is the way you can access, you can define the arrays of the workers here, and individual data you can access there. Even you can run a for loop over that. You see here, you can run a for loop for index equals 0 to index equals number of workers, and then you can print individual workers properties like hours, pay rate, all those things. So the moral here is the array. I mean, if you have an array of the structure, they are handled in exactly same way as array of any data type. So structure is a data type that reinforces that concept. So you can have the nested structure as well. Now things are becoming a little bit interesting. You have a struct person info. Now this is a struct. So basically this is a variable. Like you have a variable student, you have a structure student, CTURE structure student STU. Excuse me for this mouse. I mean, this is so imperfect. So this one you have int id, let us say. So similarly, this is a data type, right? It could be a structure as well. You can be, it can be the student, let us say the, you can define it like something else about the student. Let's say you do the demographic information and you define another structure, structure, structure demo, demographic information, and then all the things like name, address, etc. These are the demographic information. You can say demo, or it should be capitalized as per the convention, demo X. So, I mean, you can import a structure inside the structure. And here, for example, you define the personal info. Then you have a student, you have student ID. This is kind of demographic information, or I mean, it's a personal info. They call it P data. This is the variable, this is the structure. And this way, including another structure inside one structure is called nested structure. Okay. So members of the nested structures, I mean, they are accessed in the same way, but how do you access, let us say for the student, if you have initialized the student as student, define the student as student s equals, I mean, all those informations are, let us say you have populated. Now I want to know the address of the student. How do you access that? You can do it in a very simple way. You have s is the variable. So all you can do is s dot, okay, s dot p data. This is structure, then dot address. So you have to travel 3 levels here. That's why it is called nested structure. So you have to call the student. I mean, here it is instantiated or it's defined. Then s dot p data. That means you are getting hold of this personal info structure. I mean, this variable, and this is a total. This is structure. You cannot print it. So you have to do another dot to access the address. So from here, you could do the same thing, like you could do personal info p, and then you have to do p dot address. So here there is no nested structure, but here there is a nested structure because inside student you have put personal info. That's why you have to do 3 dots. I mean 2 dots basically. You have to travel 3 levels. Okay, I mean, any confusion? So you can use structure as function arguments. I mean, I mean, there is no problem in that. You can define a function. Let us say, let's do some code. Let's not use the slide all the times. Let's use the code. So if you go here, same example, you have the employee number, all those information is there. Let's define a function. Let's say you are doing, um, let's say we want to calculate this gross pay in a function. Okay, so you can do double get gross pay, and the argument is, let's say, payroll employee MP. Okay, this is our signature of this function, and now we can prototype. We can write the full function here. So this one here, let's say we want to calculate that. So let's say we do double gross pay GP. I'm writing GP equals, we are passing a structure, so we can do emp dot, um, you know, uh, hours times emp dot pay rate, right? And then you can do a return GP. That's simple, right? So here, if you do a parallel stuff, like you can do um, employee number, employee name, and then instead of calling the gross pay directly, you can do get gross. Sorry, what is going on? It should be gross pay, not H. It should be G. It should be G. So we can do get gross pay, and then we can pass EMP, right? So we pass this argument, and then if we recompile the program, let's see, I mean, this is the structure of the program. What we did, we, of course, we defined the variables, we defined the structure, then we defined a function where we are passing employee as an argument, and then we are calculating, I mean, basically calculating the gross pay and getting the gross pay here. So these two numbers should be the same. So if we think like that, let's clear first. Yeah, now we can compile. So if you compile it, you can see they are same. So we get the this in that way. Okay. So we have done that. I mean, let's not try to expand on that. Now, using value parameter for structure can slow down a program. I mean, waste space. I mean, using a reference parameter will speed up a program, but function may change data structure. Using a constant reference parameter allows read-only access to reference parameter, does not waste space speed. So, this is not just for the structures. This is for anything. But why we are talking about it in the context of structures? The answer is structure contains lot of data, lot of properties, lot of data elements. So by definition, this occupies memory, lot of memory. So that's why in order to ease that memory load, if you pass by value, it will consume more memory in terms of space, and it will take more time to process. But if you pass by reference, that will speed up. But then, the function may change the data structure. Sometimes, the data structure, I mean, sometimes the change of data is desired. For example, you could call a function that does not return a value, void calculate gross pay. Then you can just use the entire student structure, pass by reference, and then just recalculate the gross pay. And then after you call this function, your student structure will be different. It will reflect the gross pay as well. So that's how those are the notes. So you can like next item, let's go to the next item, recurring structure, returning structure from a function. Yeah, I mean that is also viable. Like simple example, we don't need to go too much discussion in this topic, but you can do like here, instead of returning double, you may returning um, like your structure itself. So you can do uh, payroll, and then you can do EMP, you know. So you have to do EMP dot GP, sorry, uh, dot gross pay equals GP. You are setting the value. Now, if you come here and then you can do get gross pay dot gross pay. So that is your employee instance of an employee. This represents an employee, and then the gross pay of the employee. So if we just compile it and run it, they should represent the same thing. See? So that's about your returning a structure from a function. So I'm not getting into detail. And then using structured binding declarations with the structure. This is important. A structure binding declaration defines a set of variables and initializes them with the values that are stored in a structure. This process is called unpacking of a structure. So let's see, like you have the general format like auto, you are using the auto variable here. So just a second. So we are talking about, yeah, that's fine. So it's basically this is basically a pointer to the structure. So let's understand it in this way. Uh, you have not really pointer. I mean, you are defining the general format to be the auto, and then you can have this way. Like you have automobile as the structure, then you have make, year, mileage. So now you can do automobile, car. You define the structure in this way. Then you do the auto, like first, second, third. I mean, that way, if you define it, then that maybe equals car, and then you can do the first to be Porsche. I mean, this is the way, this is a template kind of thing. This is the way you can get for this one first to be the Porsche, second because it's the year we get 2020, and then third one because it's the mileage basically you get the mileage 12400. That's the binding structured binding declaration. So you can see the example here. I'm not going into the detail, but now the more important thing is pointers to the structured. Whenever you have C++, pointers are constantly are in are of importance. So when you do the pointer, the structured variable has an address, right? So you place anything that you place in memory has an address. I mean, the memory address. The pointers to structures are variable that can hold the address of the structure. So you define it in this way. Now you can use the reference parameter ampersand to assign the address. So you can do the student pointer to be equals this one. We have done, I mean, it's no way different than any other variable. Using the pointer along with any other variable, it's exactly the same. But structure is a new type of variable. That's why the discussion comes. So uh, if you want to access the structure member, you can do it in this way. This guy, student pointer dot student ID. You have to use this parenthesis to the dereference pointer. This pointer is called the dereference pointer. In general, this one, the ampersand, this is called the reference pointer, and this one star is called the dereference. So using the dereference, you can get the actual data. Using the reference, you can get the address. Those are the two basic understanding, the two things that we understand in a very basic way. Okay, so any any question in this aspect? Okay, so let's move forward. So here, like we can get the student ID in this way. And again, this is no way different from our standard definition of the pointer. Now, you could eliminate this thing. This is very boilerplated thing. This does not look good to the modern programmers. This is like a C programming style of code. So you can use the same code, you can get the exactly same result using this arrow pointer. I mean, using this arrow symbol. You do the student pointer arrow student ID, you get the exactly same thing. So you are getting the value of the student ID. So it says that given your student pointer, it gets you the value of the student ID. It's more like English language speakable, but this one is very like uh, it's different. I mean, it's a very primitive type of programming style, but this is modern because you can speak your language when you write the code. I mean, here the intent is given your student pointer, you get my student ID from my student pointer. So this is what we can do. Student pointer, the data type of student pointer is essentially, this is not a data type, it's basically the address, the memory address, alphanumeric memory address. And then student ID, I mean this arrow and student ID, the whole thing, it's an integer because student ID is an integer. So you have the example here, you see the get data, then you have the student, and then you pass uh, the pointer basically this then you get student name to be equals s arrow name, because you know this is the address, right? From the address you can get the name. Basically when you use this together, like this way, dereference pointer s, that means this is a uh, structure, this is a structure. And then if you do dot name, then you get the value. But then in the pointer arithmetic, when you do the arrow sign, that means you get the name from the student pointer, s pointer. So then you can do the ID number, you can get the credit hours, you can get whatever properties you define in the student object, I mean sorry, student structure, you can get all of them back. But here the advantage is, instead of passing the whole variables, you are just passing the pointer, the address. So for example, if you change something on the student in here, then there it will be changed, because whenever next time it will be accessed by giving the pointer to that reference, to the address, then that address will store a different value, and then it will give you the different value. So you are not passing the entire payload of the structure. Maybe this is a very memory sensitive pointer, I mean structure. So you are not basically passing each of each bit of the pointer here, you are just passing the address, which is very simple data structure. So there is a gain in passing by the pointer, gain in terms of you are saving a lot of computing time, saving a lot of memory. So enumerated data type, enumerated data types is a programmer defined data type. So enum, some people call it. It consists of values known as enumerators, which represents integer constants. So here, for example, if you have a day, you can have Monday, Tuesday, Wednesday, Thursday, Friday. The identifiers Monday, Tuesday, Wednesday, Thursday, and Friday, they are listed inside the braces are enumerators. They represent the value that belong to the day data type. Okay. So your when you define enumerator, you use the keyword enum. That's how you use it. And so let's try to give an example. Okay, let's try to work on an example. I mean, we can define, but let's work on some example to get a more get a better understanding. So enum example dot cpp is the file name. So once you do that, um, create the file. Here you are. Let's clear it. Now, as usual, we can do. I mean, what we are trying to do, we are demonstrating the enumerator data type, and then we do int main, you know, return 0, our shell. Let's say we are enumerating the water, some. So water as freezing water and boiling water. The temperature, the freezing temperature is 32, boiling temperature is 212 degree Fahrenheit. Now, if we try to get those, let's say we have the temperature. Okay, temp is the temperature. Now you can do like current water temperature. We can say um, temp equals 100. Let us say. Okay, temp is 100. Now you can say if temp less than equals, you know, you can say uh, freezing, because you have already defined the enumerator like that, freezing. Then you can say cout, and you can say that the water is frozen, of course. If it is less than freezing temperature, that should be the case. And then you can say else if temp greater than equals boiling. So you are not using any specific value, you are using the enumerator here. Cout, the water is boiling. Okay, and then we can say else. You can say like that. The water is not frozen or boiling. Okay, so if you have a code like that, so we use the enum as water. So we do that, and then if I do g++ dash o enum ex1 dot exe enum example, and then if we run it enum ex1, then you can see that water is not frozen or boiling because it's in between. I mean, 100 degree Fahrenheit is not freezing temperature, not boiling temperature. But on the contrary, if you write it like 500 degrees Celsius, I mean 500 degree Fahrenheit, then if you compile it and run it again, you can see the water is boiling. So it should be boiling, not boiling. Okay, so that's how your enumerator works. So once you have created an enumerated data type in your program, you can define the variables of that type. So it also serves you as a data type. Use a day and work day, things like that. This statement defines work day as a variable of day type. We may assign any of the enumerators like this one to the day. The difference between any other variable with enumerator is enumerator can assume in some specific discrete values, but other data types can have any values, any continuously distributed values. That may be a difference between these two. But enumerators are very useful, whenever in a website you define some drop down menu, you use the enumerator. You can use the enumerator there. So enumerator is an integer named constant. Internally, the compiler assigns integer values to the enumerators beginning at 0. So if you do that, day equals Monday, Tuesday, Wednesday, Thursday, Friday, in memory, actually, your values are 0, 1, 2, 3, 4. That's how it is defined in the memory. Now you have the enumerated data types like that. I mean, you use using the day declaration, you can use the following code, and then this will produce like this one. That's why actually, you in our example, we actually initialized I mean, we defined the numerical values for our water uh, enum. So here you see this water enum, these are the numeric. If we don't use 32 or 212, then it would be 0 and 1. But we have initialized it to certain values. That's why they are representing those values. Okay, so it follows some discrete structure here. So you can, that's what I was saying. I mean, you can, you, I mean, if you do this work day equals 3, it won't work because it can assume only certain set of the values. So you can do work day. I mean, you have to do a static cast to the integer that way. I mean, it's by force you can do that, but you can assign an enumerator to an int variable. For example, you can do int x and then you can do x equals Thursday, then it will be 3 from the above example. So you can compare the enumerator values easily because they are basically integers, right? So we have done it. O- So you can use the anonymous enumerator as well. Means anonymous means it does not have any name. You can do it just anonymous way. So if you do it in an anonymous way, let us say you are doing this one. So then what you do, let's say you define two day variables, day one and day two, you know. So you have day one equals Tuesday, day two equal day one plus one. So it will not work. The third statement will not work because the expression results in the integer value of 2 and you cannot store an integer in an enum variable. Internally in the memory, they are uh, used as an integer, but you cannot just store an integer in an enum variable. So you can use the math operator in this way. You have to do static casting. If you do so, then it will work. So using an enum variable to step through an arrays element, you can see enum day, Monday, Tuesday. I mean, this is an enum. Then number of days is 5. Then you can do cells number of days. So you have cells Monday. Monday is basically 0. Tuesday is basically 1. Wednesday is basically 3. But not, you cannot set the value. It's internally. So that way you can do that. So we have done this. So enumerators must be unique within the same scope. You know, they must be unique unless strongly typed. For example, there will be an error if both of the following enumerators. So you have the presidents and vice presidents. If you do that, um, there will be an error will result if both of the following enumerated types are declared within the same scope because this is already used. Okay, whatever you have used in one place, you cannot use it another place because it is already declared. You cannot declare twice within the same scope. You cannot declare an element of the enumerator, in this case the Roosevelt. You cannot declare it twice because um, then there will be duplication, and the enum data structure does not like that. So you can use the strongly typed enum, like you can do this one enum class president, enum class vice president. That is doable. Uh, the strongly typed means prefix the enumerator with the name of the enum followed by dot dot. I mean that double colon operator. So you say president's praise, and then you do this one, and vice president's, you can do this one. So you can use a cast operator to retrieve the integer value as well. So this is the way you can do it. So declaring the type and defining the variables of one statement, I mean, there are multiple ways you can do it. So you can declare the enumerated data type and define one or more variables of the type in the same statement. For example, here, this code declares the car data type and defines a variable named sports car. Okay, so you are I mean, this is of the type car. So that's all about the enumerator. So why the enumerator was discussed in the same context of our structure, because it's essentially a structured variable. So that's concept of the enumerator. So in this particular area, we have couple of um, we have a couple of lab assignments, and let's go through the lab assignment a little bit before we conclude the day, conclude our day. So if I go to the lab assignment, learn, I so if I go there, here. So let's go to the module 5. So your lab is here. So you have this, the difference between previous labs and this lab is that I did not use any uh, like starter code. Everything is on you. So because this is structured, so it should be simple, but don't hesitate to reach out if you have any problems. I want you to be independent, so that's why I'm using this. I'm not using any code template anymore. Just use your own preferred template, but write the program, debug it multiple times, and then we can discuss if there is any problem anywhere. So that's about it for this particular session. So this is the time you can ask any questions to me. Is there any questions? Okay, if there is no question, then we can conclude the day, and we'll see you next week at the same time. And in between today and the next week, if you have any questions, just as many of you are doing actively, just send me a note by email. You can send it through Canvas email. You can send it through the school's email. I'll be responding to you as fast as I can. So that's about it. And again, I mean, uh, a- an alert. I mean, many of you are not submitting the assignments regularly. So the school's policy is to exclude students who are not submitting anything. I'm not enforced that particular requirement yet, but uh, from next day or from the next day, I'm going to enforce that. So please submit your assignments. I mean, if you are falling behind, you can start it incrementally, like submit one assignment, one additional assignment every week. That way, you will catch up pretty soon within 3 or 4 weeks. So that's about it. And if you again, I mean, follow through the module, like do the readings of the book, that is important. Practice your programs on your integrated development environment, in which is VS Code in your case. If you have any problem with VS Code, let me know. If you cannot write a code in VS Code, because last week actually I showed you the website. It is there in the VS Code tutorial as well. So you can go through those VS Code details, how to install it on MacBook. Windows is pretty simple. MacBook is little tricky, so you can do that. So that's about our, I mean, our discussion today. So if you do not have any more questions, then I would like to unshare my screen at this point, and we'll talk soon next week. Thank you so much for attending this class.